Okay guys, one of the last videos you're going to see or watch is over specific heat. The only questions that you'll get over specific heat are probably problem-based. So we'll look at a couple sample problems in class together. I'm going to show you one how to work it out here, just to kind of give you an idea. And maybe you can figure most of it out on your own or be able to practice it. The formula is given to you on your reference sheet. It's called the change in enthalpy. It's right up here at the top. It's right there at the top where I just marked blue. And then you also are given the actual specific heat capacities of water that are right there highlighted in blue. Okay? So let's talk about specific heat. I gave you this in your notes. Specific heat is how much heat energy does it take for you to heat up 1 gram of a substance, any substance. Metals, water, alcohols, liquids, gases. How much heat energy does it take for you to heat up 1 gram of that substance by 1 degree Kelvin? That would be like saying, I've got a bathtub full of water. Or no, not a bathtub. Let's say I've got 1 gram of water. 1 gram of water. And I put it in a pot and I want to heat it up. How much heat do I actually have to apply to that water for it to absorb enough energy, right, to raise the temperature of 1 gram of it by 1 degree. So these are specific values that are known to us, but let's say we have more than 1 gram of a metal, and let's say we have a specific temperature changed. We need to be able to figure out how much heat energy did we actually add to a substance, or be able to calculate an unknown substance's specific heat. Okay, so these are the formulas that you might see. This is the one right here, matches this one. It's typically on your reference sheet. It can be manipulated or changed if you're asked to actually calculate the specific heat. So if you're asked to calculate specific heat, that's this little C. Sometimes you see it as CP, and it's called specific heat capacity, right? Or you're asked to solve for heat energy. You'll be given the specific heat, which gets plugged in your formula here, and then you're asked to actually solve for the heat energy. So let's break down this formula. C stands for specific heat capacity. The units are joules per gram Celsius. How many joules of heat energy does it take to raise the temperature of 1 gram by 1 degree Celsius, right? The Q actually stands for your heat energy, which is measured in joules. M stands for your mass. It can be in grams or kilograms. Typically, you're going to see it in grams. The change in temperature. Delta T, this little triangle T, means change in the temperature. The temperature can be in Celsius or Kelvin. It does not matter because you don't want the actual temperature. You want the change in the temperature, right? You want to calculate the change in the temperature. It went from this to this. Find the change, and that's what gets plugged into your formula. All right, so let's work through a problem. You can pause the video if you need to write those things down. The problem that you're going to want to write down and work out with me is on page 552, number 9 in your book. So I'm going to work through it here. If you need to pause, write, and then play again. You need 70.2 joules to raise the temperature of 34 grams of ammonia, which is NH3, from 23 degrees to 24 degrees. Calculate the specific heat. So the first thing you want to do is go through your actual problem and underline the step that's important. So 70.2, the unit is joules. So above that, I just kind of write what joules stands for. Joules is telling me my Q, right? To raise the temperature of 34 grams, the unit is grams, which is telling me that's my M. Ammonia is what I'm dealing with, from 23 to 24 degrees Celsius. So my temperature change is 24 minus 23. Typically, you're going to have a much bigger temperature change, but you have to find the change in your temperatures before you can start plugging and chugging, all right? And then it's asking you to calculate specific heat. Specific heat is that little CP, or C. So the formula I'm going to use is C equals Q over M change in T. Straight up, plug and chug. All right, so I'm going to start plugging in my numbers. I'm calculating specific heat, right? My Q is my joules. unit. That's how I know what the Q is. I'm looking for that unit J for joules. My mass is 34 grams. The change in temperature, now you can either write this down here. Change in temperature was 24 minus 23, which is a 1 degree change. Or you can either plug it in here, 24 minus 23. I prefer to do it here. That way I can just plug the actual change here. So the change is 1 degree Celsius. So now here I have simple math, order of operations. I have to multiply first before I can divide. Well, 34 times 1 is 34. So C equals 70.2 divided by 34.0, right? Obviously, that's going to be about 2, but I'm going to double check on my math. 70.2 divided by 34 is 2.06, right? In your multiple choice answers, you can find either one. You might see 2.06, you might just see 2. But you have to check your units. So look up here in your problem. It's very important when you're working your problem to plug your units in as you go so that when you get to the bottom, you can look here and see, does any of this cancel out? What am I left with in terms of a unit? And here I have joules per gram Celsius. So my unit would be J per gram little dot Celsius. And that's it. That's a specific heat problem. We'll work another one where you see Q as what you're solving for in class together. Or I'll send you another video.